Hello all. This video is all about interfacing the output devices along with the microcontroller in embedded system design. So here we have Smith trigger inputs, ports, PX. The voltage power supplies are given. Minimum voltage power supply, maximum voltage power supply for the input device is given. So positive going input threshold voltage, negative going input threshold voltage. Input voltage hysteresis, pull up and pull down resistors in the input values, input capacitance, input resistance. All these values are given here. So this is for input. Input is nothing but the voltage, which can be either VSS or VCC. Both are considered as input voltages. The leakage current will be calculated from ports PX. We will be having 4 ports, P1, P2, P3 and P4. High impedance leakage currents will also be a parameter, and we will be supplying power supply of VCC is equal to 3 volt. So the maximum voltage would be plus or minus 50. The output port PX produces a voltage high level of VOH and voltage low level, output voltage low level output voltage. Okay. So, and the current is, the output low current is 6 milliampere, output high current is 6 milliampere negative. VCC is 3 volt, minimum power supply is 0.3 volt. So, output frequency we have to know. The output frequency also will be provided in the ports, clock output frequency. Next slide is all about the rotary encoder. The input high level, low level for the A input and B inputs are given here in the rotary encoder. Encoders are usually used to encode the data before transmission. And in the receiving end, what we have to do is we have to decode the data to bring to its original form, and then only it can be read. Interfacing the physical world to the output devices. Output devices are usually displays or LED displays. This LED display can be RGB LED, or it can be addressable RGB LED or a 7-segment display or LCD display, or it can also be a sound output. Relays can also be output device. Motors can also be output device. Heaters, Peltier modules, DC motors and stepper motors are called as the output devices, through which we can see the output. LEDs are also best examples. Separate LEDs, LCD displays are best examples for output devices. So LED 1 and LED 2, high side control, and LED 3 and LED 4 are for low side control. We have a microcontroller provided with a power supply of a VCC, and LED 1 is connected with resistor 1, LED 2 connected with resistor 2, LED 3 connected with resistor 3, LED 4 is connected with resistor 4. LED 3 and 4 are connected together and they are provided with a VCC of power supply 5 volt. So these are the controlling LEDs. LED 1, 2, high side control. LED 3 and 4 are for low side control. So from this we are going to learn about the voltage drop across an LED, value of a resistor, and we have to calculate the value. So that is the actual purpose of this embedded system. Finally, the output will be displayed in the form of 7-segment displays. Why do we call it a 7-segment display? Is because the first line is called as A, B, C, D, E, F, G. So when all the letters are on, then we will be getting H. When G is off, we will be getting 0. So when F and E are off, we will be getting number 3. Likewise, we can display the numbers. So because of that reason, we say it as 7-segment display. So here we have microcontroller which will be connected with 2 7-segment displays, common cathode, 1 7-segment display will be connected with a port and another 7-segment will be connected with another port. So this is the driving of 7-segment displays. Here the last segment is connected with a transistor and a resistor.